This is Matthew Goodenough, ENGR-120, Lab 7 for DC Circuits, Section MO1. And this is the circuit we made today for lab, actually. We have our voltage supply source, resistor R1, which is measured to be 200 ohms, resistor R2, which is meant to be 330 ohms, and our biggest resistor R3, which is 510 ohms. And we also made our own V0 voltage source using a IC chip of a 741 amplifier to help make that V0. So right now the multimeter is measuring our V0, which would be 6.060 volts. And then at our voltage source, we are getting 10.06 volts. And that's what is reading there. And then to measure our current, we must break the circuit, which I will do. So here we break the circuit and we read our I1 measured value, which is 14.24 milliamps. And I know I got some different values here, but that was from what I did in lab, and I tried to make the circuit again. But this is what I got to work with, so when I did all the same procedure, I had a 10 volt, and then my V0 was 8.45 volts. And then when I measured my current, it came out to be 12.10 milliamps, and I did it the same way I did here. But so after you do that, the next procedure was to compare your results. So now that was measured exactly, actually, and then now you have to do it theoretically using KCL voltage at extraordinary node, and see where our extraordinary node is there. And we get this equation. And then you also solve this using WIM's linear solver, or you solve this one by hand. So we just solve for VA. I found VA to be 7.5674 volts. And also when I measured that node voltage at VA, I got the same, around the same. It had some error, but not a lot. And same for the theoretical, I got 12.16 milliamps and 0.0862 volts at voltage source 2. So at that V2. And when I did my measurements, that's what I got from my circuit. And that should conclude for my circuit 1 for Lab 7 ENGR-120. This is Matthew Goodenough. Thank you for listening, and that was my lab.